This was kind of what it was like when we started. Just a hillside, lots of weeds, rock hard soil. In fact, it was rock. Nothing growing that could provide any habitat. Neighbors were using it to dump trash because, you know, it was a lot cheaper than going to the dump. It was also the place of crime scenes. And it was just a very nasty, unloved, forgotten piece of land. But it was right on the other side of a chain link fence of our school. One of the students in my advanced placement environmental science class looked out the window through the chain link fence and she said, you know, we could do something out there. We just learned all about it in restoration ecology. We've learned how to build soil by adding organic matter. We've been learning about ecological succession, and we start with the annuals and then we move up eventually to get a forest. Why don't we do it? Why don't we bring back all the native plants from around here? Why don't we make it like a botanical garden with a riparian zone and a grassland and an oak woodland and a mixed woodland and a redwood forest and a grassland and a chaparral? Why not? And guess what? All the students went crazy and applauded her, and the principal said yes and cut a big hole in the chain link fence, and we went out and started working. The year was 2000. And every month since then, students and parents and staff and professional volunteers have come out to work this land and make it what it is today. And it is exactly what she envisioned. The Center for Environmental Studies is a bright light for us, built in 2014. But in 2000, we couldn't even imagine that we could make that happen. What we had here was this hill was actually a pile of unconsolidated construction debris from building the theater. It's the sort of thing that is actually illegal under the Clean Water Act because it can erode. So the first thing we did was to plant plants like the ceanothus right here and the white sage and lots of different species, and what they know how to do is to send down deep roots, get their water, and hold on. And so they held on to this hill and made it possible to have a flat area up here to do things with, to hold classes. And now this hill, nobody can imagine what it used to look like. Now it's just so lush. Forests. What are they like? We had to think about that before we decided where to put our forests. Forests need more water than the grasslands and the chaparral. They need good soil, same thing. Where's that going to be? It's going to be down the hill where water collects and where soil flows off. And these forests here, some people say they've been here forever. But no, these were planted in the year 2000 and since, and they look like they've been here forever because they've got everything they need. So now we're going into the Coast Live Oak Forest. We have this incredible grove here. I'm going to walk into it to show you. Can you believe these trees are only 24 years old? We planted a grove exactly where it wants to be. Not in the water, not too far from it. And look at these gorgeous, they have these multiple trunks. Oh my goodness, I'm going to walk up to this one and give you a closer look. They always have multiple trunks, which makes them a great climbing tree. So I think I'll climb up just a little higher because that's so much fun. And I want you to take a look at this cracked bark. These trees are still young, but the really old trees have incredible ridges and cracking. These are still babies. You can notice that there's lichen on the bark. These cracks are places that little spiders and all kinds of insects make their home, and that is providing food for the birds that we can hear up in the tree right now. If you look up in the canopy, you'll see a whole network of branches. And this is a great place for nesting and lots of birds to live. This coast live oak tree is part of a family, the oak family, which gives us acorns. We don't have any right now, it's the wrong season. But acorns provide food for so many different animals. The scrub jays, the raccoons, the wolverines, everybody takes this food, and Native Americans depended on it. This area had some of the highest populations of Native Americans in California, and that is thanks to these oak trees and other oak trees that live in this area. Really high protein food. Oakland was Oakland. The whole flat area where the downtown is right now was a huge oak woodland with trees that were 300 feet wide, with massive trunks. And that oak, those oak trees, unfortunately, provided the hottest burning wood of any wood. Super high fuel capacity. So when the gold rush came, and all this money came in to build San Francisco, and the redwood trees were being cut down, guess how it got to San Francisco? They cut down all the oaks, and they used it to burn them in the steamships that carry the redwood to San Francisco. That's the history of oaks. Now, wherever they can, we grow them, and we've got them here, a very nice grove supporting wildlife and us. So I want to talk a bit about how to grow up a forest that feels like it's always been here. Forests have understory plants, and I want to show you some of the ones that we have coming up in this young oak forest. So up here, we have madrone trees. These are the native ones didn't do very well. They don't like people to plant them. They want to plant themselves. So we have a very closely related garden variety, which is Marina madrone, and it's doing fine. So we've got that in the understory, meaning under the dapple shade of the trees. And then over here, we have another one, which is a western redbud. Look at these lovely heart-shaped leaves. And then the other thing that happens that's pretty exciting is that plants volunteer because we're doing something right for them. And at my feet are all these kind of wiggly leaves. This is soaproot. They're dying back right now because it's the end of spring. But they have underneath them this big bulb that can be used to eat or make soap. And they've been volunteering under the oaks where they like to live, as if they were just waiting for these trees to come back here. It's pretty exciting. There's quite a number of the perennials and other understory plants that are coming back. So the Living Lab is like everywhere else, experiencing dramatic climate changes. And we're seeing the impacts in all our communities. Coast live oaks, I'm sad to report to you, are experiencing disease problems that they've never experienced before because of warmer temperatures, making it a much friendlier environment for invasive pathogens. And I'm going to introduce you to a couple of those that we're dealing with right now. This beautiful tree has a condition called anthracnose. It's a microscopic pathogen, but it's getting in there and causing serious leaf discoloration, and that can decrease its photosynthetic capacity. We recently had to treat this with a chemical just to save the tree. Even though here in the Living Lab, our belief is we don't want to use any chemicals, and we've done everything we can all these years to not have to use any chemicals, but now we need medicine because for these pathogens. All right, I'm going to show you another one that's pretty scary. So this coast live oak, as you can see, it's got this very dark, rather moist scar. And this, my friends, is what sudden oak death looks like. And this is a disease that's killing oaks all over central coastal California. When I saw this, I was devastated and brought out an expert who took it to the lab and said, we're in luck. Though it looks like sudden oak death, it's not. It's something else. It's not great, but it's going to last a long time. We got to keep an eye on it. This is what's happening, you guys. Climate change is bringing in these diseases, and we're at risk of losing the forest that make this place the natural environment that all these animals depend on and we love. So we really get it right here that this has to be addressed. In the meantime, what we're doing is adapting to it as best we can. Where there's water, there's trees. We created this pond and the stream, and this is the natural home for a redwood grove. You can see our young redwood grove right behind me. I'm hugging a coast redwood. Its scientific name is Sequoia sempervirens, which means evergreen, which you could think of as ever living. How does it do that? Well, it's ever living for up to 2,000 years. This is only 24 years old, a baby. But one of the ways it can do it is this thick bark. So I'm grabbing it, these nice furrows. There's all this fiber. This is a fireproof coat that redwoods have. And they are protecting it from our fire ecology in California. If it didn't have this, no way it'd make it to 2,000 years. And in the fibers, there's life. Little spiders, all kinds of insects, and they're just taking advantage of this beautiful home the redwood is providing for them and everybody else. So I'm walking into our redwood grove. We have two of them actually. This is pretty special. And these trees are our California state tree, thanks to being the tallest tree in the world. I want you to take a look at these needles here, along with the tiny little cone. And the needles are one-dimensional. They're not round around the stem. See, it's flat. One side is kind of light with a green stripe on each needle, and then the top is a darker green. So this is not a pine tree. It's not a fir tree. It is a coast redwood. Check out these tiny little cones right here, and I'm going to show you something else that's amazing. Right here, I have a cone. Here's the littlest cone of all the conifers, the cone trees, and it's got the tiniest seeds too. Look at these little seeds. They're the size of a tomato seed, the tiniest of all the conifers, yet this is for the tallest tree there is in the world. Now, these seeds are only an insurance policy. Redwood forests don't grow their trees from seeds unless a catastrophe happens. A big landslide and the forest falls down, and light comes into the forest, and that shaft of light hits the ground, and one of these tiny little seeds turns on because it's got sunlight and grows to fill that gap. So the vast majority of the trees, the seeds don't ever sprout. So now you know that seeds are an insurance policy for when there's a disaster. If there's sun that comes in, a tree can sprout. But redwoods have a more important way to just keep going, generation upon generation. And that's something called a burl, which is a concentration of cells that are, you'll often see where a tree has been cut by a trail, you'll see this round thing that's there. And all around the edge of the trunk, they're there, but mostly you can't see them. They're there, so if the tree is cut down or if it falls over, it's going to sprout again. When the gold rush came and all the trees were cut in the East Bay, Oakland was the center of the redwood forests. The trees were cut to be carried across the bay on the power of the woodlands, of the oaks, and built San Francisco. Amazing. But the forest was completely devastated, and all the animals and all the people, the native people who lived here, thought the end of the world had come. And for many it had, but not for the redwood forest, because they know what to do. Those little burls buried deep in the bark started sprouting. And what happens when they do that is the mother tree, which could be the size of this circle, start to sprout around the edge. And you can go to the parks around here and see fairy circles with a circle of redwoods just like this are sprouting up. The redwoods know about resilience. They know how to recover. And we've mimicked that here. So this circle is the size of a typical redwood tree who's mature, 25 feet across. And the edge is all these redwoods making a circle. Now let's look at the shape. This tree has a single straight trunk. Straight trunk from the ground all the way up as tall as it gets, which can be almost 400 feet tall. The tallest one is measured at 380 feet. And it is going to hold them up. So right here, there's two things I want to point out to you. One is redwood sorrel, and that's a typical understory plant in the redwood forest. It almost looks like a four-leaf clover, but not quite. It has beautiful pale pink flowers. And then right here, we have these pots that were made by the ceramics department, and we put water in there and it seeps through the pot. It's not glazed. And that's how we keep these redwoods going, in addition to irrigation. This one has a special feature because it honors Mary and St. Clair. But here's Mary. Take a look at her. Can you see what she's in? Her beautiful protective canopy is an upcycled old bathtub with recycled tiles and river rock, local river rock. And this is a beautiful place to come and contemplate. Also, we have classes in here. And now, let's go see what's on the other side. We're going past Stearns Avenue here. We're right in the middle of the city. We have some more planting space and some other woodlands here. And now we come into another plant community, which we call mixed woodland. We started it with these coast live oaks that were already here, and we decided to bring in a mixed woodland, which is what you find all over the East Bay Hills, and we planted the typical understory plants that you'd find. One right here is a toyon, which has really nice red berries in the wintertime, which you can use to decorate for Christmas. And then I'm standing in a beautiful manzanita that can take some shade. And then we'll walk down and pet the beautiful soft redbud leaves that have magenta flowers in the spring. And we come to this pipe, which is a drainage pipe from the parking lot that was built up there, coming through the manzanitas and some ceanothus. We have some wild California lilac up there and some Philadelphias. So all of these are natives that like to be in this mixed woodland, which is an association of species that can take drought, some shade, and they just do their thing, making a network of community of varied species and healthy biodiversity right here. And near the redwoods and under them, we have western dogwoods, which have beautiful white flowers in the spring. And then we have red elderberries, which in the fall will have red berries. And they have these beautiful divided floppy leaves. All the trees in the Living Lab have been planted in memory of someone precious to a member of our community who has passed on. This circle of redwoods is planted in memory of Costa, who was a student here. Her parents discovered that planting trees watered by their tears is the most healing thing they could possibly do. And so every year on her birthday, we've been planting trees, inviting the community to come and plant a tree in memory of someone they've lost. Trees in the Living Lab teach us that through community, we can heal. And the trees and forests in the Living Lab are community for each other. That's how forests work. The roots are connected through mycelial threads of fungus. They communicate with each other. If one's not doing well, they send food, they send energy. They hold each other up. Redwoods in an earthquake, despite the fact they have short roots, hold each other up like they're on a trampoline, and they can do it. They can live in earthquake country and be 350 feet tall and not fall down because they hold on to each other. We can learn a lot from them. Redwoods are our teachers. Trees are our teachers here. And now we have to give back the care they give us. The redwoods, whose range is limited just to a 30-mile wide stretch from Monterey up to the Oregon border, because that's where the fog is. They're here because of the fog. They have short roots. They gotta have it in the summer when it's dry. But now with climate change, the fog's not coming. So we have to give back to them. We irrigate them here in the summer. And I hope they last a long time. The orchard is one of our first projects. The first thing we did was to make these swales, which now look like trails. But what it did was to collect rainwater and soil when it was rolling down the hill. And I'm sitting right here on a swale. You can see this sort of hump here. And we have a series on this steep hillside with rock. And so we then built soil by adding a lot of organic material and like bark, and then we collected the rainwater and it percolated down through the back part of these swales and started to build up soil, because where there's water, there's life. And when water comes, the organisms that make soil will come. And when we had some soil built up, then we realized a dream. We planted an orchard. We're in the orchard right now. We have 40 heirloom fruit trees who produce fruit every fall. Every one of the trees was planted in a big memorial service, which was extraordinary. Some of the trees were planted in honor of graduates by parents, some in honor of their grandparents who had passed on. There's family roots in here, woven into the roots of this orchard. This is a place where we started with no soil and grew soil, and now we've got food to feed us for a long, long time. We're looking at our state rock. This is serpentinite, otherwise known as serpentine. You see it all over the East Bay. You find it where there were tectonic plates that ground against each other. It's greasy, it's smooth, it's a terrible rock to build on. Houses slide down, it has no nutrition. But it has a unique community of plants, just like this one I'm standing next to here, which is a desert willow, who loves to be on serpentine. Most plants don't. The story of this pile of serpentine that we've gotten plants to grow on is that a parent had a construction site and he said, you know, would you like a pile of serpentine? Because of course they needed to get it off site so they could put a house there. And I said, sure, we'll have another plant community that we can have in the Living Lab. Little did I know that I would spend many years trying to find plants that would be happy here, and we've done it.
Okay.
The desert willow has these lovely flowers, and next to it we have the California buckwheat, which is a beautiful plant. This is just about to bloom. This we planted immediately. It's been here now for 20 years. California buckwheat, it's got these little narrow leaves, and when it blooms, there'll be little tiny clusters of flowers. The birds love them, the pollinators love them. They are great. So I'm walking up Serpentine Hill, and this has had quite an evolution. I'm coming over to these beautiful elderberry trees that they've grown in just 2 years to be kind of a grove here. They don't mind serpentine, which is wonderful. Look at those little clusters of flowers. They die back in the wintertime and come back strong in the spring. I'm going to settle in and tell you about this spot, Serpentine Hill. So I'm on top of water tanks where we collect rain that comes from the pipes that are the drain pipes that come down the building, go under the street, and we use that water to feed our pond. This flat area is on top of those tanks. Serpentine is a good rock base to put the tanks on, and that's what we started with. But then we had all the sides that we planted with serpentine tolerant plants, like this elderberry. I'm sitting in a wonderful plant which smells so good. This is a Cleveland sage, and it's right next to a California fuchsia, which if you come over here in the fall, you'll see beautiful red flowers. And this is the only flowering plant in the fall in the Living Lab and in our native areas. And the hummingbirds just fight over them. They love them. Another very serpentine tolerant plant, surprisingly, is the big leaf maple. These have the biggest leaves of any maple tree, and these really pretty red stems. And this tree we planted 2 years ago. It's doing pretty well. Oh, the aroma is glorious. I am in a Cleveland sage in full bloom. Yes, there's lots of honeybees around me being very happy. They're going to go back to our hives and make honey. This is a chaparral plant. It lives in the shrublands in Central California. Isn't it gorgeous? We have this hillside has the conditions that plants like these love. And you can see this beautiful carpet of chaparral shrubs. Different species. We have coyote brush and 3 different species of sage and a gum plant. They all can take super exposure. Heat, wind. You can throw whatever's hard at them and they'll take it. You can see they have all these hard branches. They knit together so you can't really imagine wanting to walk through it. This provides some of the best habitat in California for all kinds of little mammals and birds. Some people say that the name chaparral comes from the cowboys and girls had to ride with chaps to get through it because it'll rip your skin up. It's so intense. Hence chaparral. I don't know if that's true or not, but it's kind of fun. This is one of our most beloved California shrubs. It's an important part of the chaparral. You can see it's got upright leaves. See how the leaves are going upright? That means they're not allowing the sun to hit them straight flat. So they're adapted to the heat of the sun that way. And they have these beautiful berries, little orange berries. Some of them are red, some orange. The flowers are pink or white. And that has these beautiful red stems and red peely bark. Well, I'm sitting in some saltbush. It's a great chaparral plant. It also likes to live in salty places. It has the ability to excrete salt on its leaves. And so if you taste them, they're a little bit salty. And the birds are loving it to death. You can see there's this section here that's gotten kind of gray because they come in and they eat the leaves. There'll be whole flocks of goldfinches or sparrows munching away, getting their salt from our salt bush here. Kind of cool. Chaparral is about sages. Here's one that's actually native to Southern California, but we love it. The birds and insects love these flower stalks. And the leaves, it's the lightest of all our sages. It smells so good. This sage is famous because people like to put it in sage bundles, and the sages that are in their native habitats have been exploited and overexploited and overharvested. So we can grow it here and right the balance, and students sometimes make sage bundles out of it. Buckeyes. The flower you were just looking at smells so good, and you may have seen a little native bee who loves it, and I love it. It has these amazing seeds called Buckeyes because some people, if they use their imagination, think it looks like a male deer's protruding eye. And this is a food plant for native people in hard times because you have to really process it to get out the toxins. So don't eat this until you do a lot of work. Buckeyes are transitional between chaparral and wet places. In the chaparral zone where there's a creek nearby, you'll likely find buckeyes along the edge or very close to it. This is a giant buckwheat. And buckwheats have this incredible organization with lots of different little florets. When they bloom, it'll be like a pinwheel of flowers, and it's just about to bloom. Very well adapted to chaparral. You can see it's got small leaves, as most of these plants do, a little bit furry. You know, the hairs on these leaves, they work like little umbrellas, little bits of shade to carry them through the hot times. These are super attractive to birds when the seeds come. Just big, wide platforms of seeds that they gobble up. This is our butterfly garden, which means it's actually pollinator garden. All these flowers are planted to attract butterflies and other pollinators. That means insects who help the plants have sex and make new babies. So that's very important. There are bumblebees galore in here right now. Even a dragonfly trying to go for some of those pollinators. There's that swallowtail butterfly. Lots of little butterflies popping around. There's always action in the pollinator garden. We have asters, we have valerian, we have different kinds of daisies like gumweed, we have native mints, we have milkweeds and yarrows and jimsonweed, datura. We have so many different plants, and valerian and verbenas. This garden attracts lots of native bees. Got one right, come back. This is datura. It's an incredibly tough plant, even though it looks so soft and pretty. It has some psilocybin chemicals in it that some native people use. Water. Water is life. And this is the riparian, the pond, the waterfall, the center, the heart, ecological heart of the Living Lab. A lot of what we do in restoration ecology is providing the conditions for nature to take care of itself eventually. And much of our planting and our various plant communities, that's what we're doing. We're setting it up to succeed over time without us. But for an artificial watering feature, you can't do that. There's things that we have to do to maintain it. Especially in California, where ponds are very rare. In fact, we hiked all over, me and students, trying to find where there were natural ponds. And the only places were where there'd been a landslide from an earthquake, and you'd have a berm, a little hill on one side of a hill that would catch water in the basin. So when we decided to put in a pond, we looked at where was in this site a place that could mimic that. It's all about mimicking Mama Nature. And it was here at the bottom of the hill where we could dig this out and make a berm, make a little berm over there to hold it in. Now, that required a lot of digging, and then we wanted it not to be a seasonal pond, we wanted it to be a year-round pond, because that's what draws the wildlife, and that's what makes people happy. When we first came up with the design, which everybody in the school contributed to, the one thing that everybody wanted was a pond and a waterfall and places to sit around it. So we had to do this right. When our hole with carpeting and clay didn't hold water year-round, we then added a liner. And the liner, a vinyl liner, worked for a while, and then somehow it got punctured and it leaked, and we had to keep filling it up with water from the city. Not what we wanted. So then we hired some people to come in and put in this professional pond. It has a rubber liner. The edges are firmed with concrete, and it's working really great. It's recycled, of course, so we have several pumps and filters at different locations, and having the waterfall adds a lot of oxygen to the pond, so it doesn't become a low oxygen environment, which is not good for fish. So we collect the rainwater that comes from the CES and the classroom building, and it comes down the pipe into 3 7,000-gallon tanks that are underneath our seating area. 21,000 gallons total, and it feeds the pond. When it overflows, we can turn it off and send it to the orchard, or if it still overflows, it goes down into our redwood groves below here. So we try to keep all the water we possibly can on site and not waste any water. When there's a drought and we have a year with almost no rain, then we really do have to fill the tanks with city water. And then we have to treat it. We have to take the chlorine out so the fish can live. So that's how we keep this going. We can't have too much algae in here, so we have to clean out this algae. Now we've got this invasive algae problem. But we need some to keep the oxygen going and good habitat and food for the fish. So it's always a balance. We have to keep our eyes on it and keep it at a good chemistry, as well as a varied habitats. We have to keep track of all these different habitats, from this little angelica here that's living in the shallow area to the trees around the edge. Remember, you gotta have trees for a healthy pond. Without shade, you have too much evaporation, and the water goes up into the air, and then you're gonna have to add water from the city. So it's all a long-term project to build and maintain a sustainable water feature that can support wildlife and make all our people happy. So we've designed this pond to maximize biodiversity on the pond by having lots of different habitats, and also to maximize the ability for students to get up close and personal with this pond and all its inhabitants. So we have platforms at many locations around the pond, and you can see you can reach over, touch the water, you can collect water samples, you can put in your nets and really get to know this pond. And we have 3 different species of fish right in front of me. There's 4 bluegills. Our native bluegills are heading towards the waterfall, and those fish were caught by students who wanted bluegills to be in this pond. We also have goldfish who were put into the pond by students who wanted goldfish, and 1 koi, and lots of little tiny mosquito fish, which keep our mosquito larvae population very minimal. You can see we have many dragonflies going crazy right now. There's territorial wars. There's mating going on. There's 3 different species of dragonflies and lots of water striders. All kinds of life are here. Now, the depth of the pond is how we determine the different habitats, because some plants and some animals like to be where the water is deep, others where it's shallow and marshy. So over by the waterfall, it's very deep, and that's where the most oxygen is in the pond, because we've got the most bubbles, and all those white bubbles are bundles of air that oxygenate that into the pond. As we get further down to the shallow zone where the marsh is, there's less oxygen, but of course there's animals and plants that prefer the shallow zones. We have pockets, like right now where I'm sitting, we have a shallow pocket right to my left, and we have access to the medium depth part of the pond to my right. Over to my further right, we have another pocket that grows plants that don't like to be in deep water, but they're great for habitat. These are sedge plants, and this is where insect eggs, aquatic insect eggs, and fish can hide and protect their young. And right now I see a blue darner hanging out in the sedge. It's a good place to be if you're a blue darner. So the marsh is an amazing place. This is where you'll see birds hanging out. I'm in the middle of cattails right now, which have delicious seeds for certain species, and of course you can see it's a good place to hide. So in the roots of the cattails, these little baby fish have a very safe home, and there's lots of food in there for them. They can hide easily until they get big enough to head out into the open water. This is the cattail flowering stalk. These are tiny little flowers. It feels so smooth when they're young and haven't opened up yet, but now they've started to open up, and you can see how sort of furry it looks. And that, when it gets a little more mature, turns into this incredible soft fur of individual seeds that are ready to fly. And this soft material is treasured by birds for making nests and by people who need soft absorbent materials. And it's a very special plant for many reasons. So you can see here in the water the roots of the cattails, how they are fantastic habitat. And all those little fibers are where the fish will hide, and also they can eat. Any plants in the water are adding oxygen to it, which is excellent. And then below it, you see these kind of curlicue plants. They're a type of algae called Elodia, and a little bit of these is good because they are a good habitat and they add oxygen, but we did not put these here. A student who had a science project had it in her bottle and decided to give it to the pond. And now it's taken over. It's very invasive. So it's a mixed bag. And we have a bluegill in the picture too. Did you catch the big bluegill? Cool. Come on, move on.
Doing him now.
Move on, move on. Another part of our marsh is these flowering plants that the pollinators love, the birds and the insects. Right now we've got these lovely yellow seep monkey flowers. They like to grow in a marshy situation just like this. And a cardinal monkey flower right here, same thing. These just are going crazy, having a great time, mixed in with all the juncus reeds. And doesn't it give you a picture of the abundance that a good water habitat can provide? So I'm walking through a riparian forest. Of course, every place you've got water, you have willow trees. They're just beautiful. Without shade, none of this would work. The pond has to have shade, and all these understory plants have to have shade. The willows are how we started it. The pond was started as just a hole we dug in the ground, and we filled it with carpets and clay and tried to get it to hold water. And we had a seasonal pond, but it didn't hold water very long. But we did start then with these trees. We've got 4 of them. We took some sticks cut from willows in Tilden Park, stuck them in the ground, and like willows do, they sprouted and have become these wonderful trees. So check out all the greenery on the ground. This is what it looks like on the streams around Redwood Park. You'll see all of these plants. There's so much biodiversity, many, many plants. And look, this is one of my favorites. Cow parsnip. It's got this fabulous flower head. It's got giant leaves. It grows over my head. And you would not think that such a flimsy leaf plant, look at these leaves, my goodness, that these could live in a drought climate like California, but if they have a stream nearby, they're happy. We have a selection of all the riparian trees that you would find in Central California. Here's one, the alder tree. Beautiful, simple leaves, so soft, and they lose their leaves in the wintertime and have lovely white bark. We love them. Here is a California classic river tree, the California sycamore. You can tell it by its unique bark that some people say looks like puzzle pieces. If you pull them off and tried to fit them all together. It grows fast and tall with these beautiful big maple-like leaves. Now they're dancing in the wind. A wonderful shade tree along a riverside or a stream side. One of the most common shrubs along our stream side is the thimbleberry. It has soft, soft leaves. In fact, if you don't have any toilet paper with you, it works great. It's got these very pretty berries that, when they're a little bit redder, are really sweet and delicious. Not now. California spice bush is a very special plant that grows along the streams. Some people think it has a spicy aroma, and you can see it also has soft leaves and is a lush plant thanks to being near the water. And over here we have our propagation center. This is where students have projects in their freshman Science in the Environment class. It's got so many baby plants in it right now, and it's also where we propagate our vegetables and other plants and native grasses. And we can have a whole class working around this main table. This is where we take care of, this is our native section, and then we've got lots of vegetables coming up too. And here we have lots of vegetables getting ready to be planted, beautiful squashes, and students learn how to start plants from seed, from cuttings, and we put it in the garden. We also give lots of plants to the Oakland School District and other needy organizations. And here we have a fabulous shade house with these tables that move so people can be around both sides of it. Here we've got a bunch of squashes coming up, and then over on the other side we've got lots of new native plants coming up. And the beautiful thing about it is that they can be watered from the bottom, so the roots can suck up that water, whereas the other type of greenhouses put spray, and that causes disease. You got this beautiful shade cloth, pretty cool. Here we have the section that's relatively new. When the Center for Environmental Studies was built here in 2014, this whole hillside was excavated, and so we've had to start over with our restoration efforts. And so you'll see a number of trees that are adapted to very tough soils because there was no soil development here, and they also are trees that are well adapted to our changing climate. You can see they're very young, and then we have other plants that can handle these very tough conditions of poor soil and total exposure. But most of them are doing really well.